Hi everyone, let's talk about weather, and we're going to break up the video into two parts. So in this first part, let's begin by discussing humidity. Humidity is just the quantity of water vapor that presently is in the air, and it's helpful to talk about the relative humidity. That's the amount of water vapor in the air divided by the maximum possible amount of water vapor, all times 100 in order to make it a percentage. And then, when the air is really sticky, there's a lot of water vapor in the air at 100% humidity, well, then something special is occurring. If you think about some air over a body of water, like maybe the ocean, at 100% humidity, water is evaporating, changing from a liquid to a gas at the same rate the water vapor in air is condensing back into a liquid. And if you think about water vapor higher up in the atmosphere, well, then little tiny droplets of water can condense. And these little tiny droplets can shrink in the air as they evaporate, and they can grow and get bigger as they condense. Okay, it will rain when the sky is at 100% humidity. And if you think about the air at the surface of the earth at 100% humidity, there's a special temperature called the dew point, at which below that temperature you're going to get dew. And then if the temperature in the sky is below this dew point, it's going to rain. So the dew point's kind of a nice number. And it's defined to be the temperature to get to 100% humidity for a particular amount of water vapor. So if the air is pretty dry, then that air needs to be cooled down a lot in order for it to reach 100% humidity. And if the air is really humid, well, then it needs to cool off just a little bit in order to get to 100% humidity. And if you're talking about water vapor at the ground, if the temperature has to dip below freezing in order to get the 100% humidity, well, then the air can condense right out of the atmosphere as water vapor and directly into ice or frost. So we can get dew to form like in the summertime if the air is really humid, because overnight the temperatures drop. And they can drop to the point at which you achieve 100% humidity, and then water droplets can just grow right on blades of grass, and you get dew. And then in the wintertime, if you have some humid air and the temperatures drop overnight to below freezing, well, then instead of water vapor condensing out as little droplets, it turns into tiny little flakes of snow or ice directly on those blades of grass and forms frost. And you've experienced dew perhaps in the summertime if you're drinking some cold lemonade outside or just a cold glass of water here. The temperature of the glass itself is colder than the dew point, and so as the moist air contacts the cool glass, well, it dips below the dew point and little water droplets form. And that's because the rate of condensation equals the rate of evaporation for this cold temperature. Okay, something else we have to understand is atmospheric stability. And there's two situations. You can have stable air and unstable air. And if you push up some air, either through wind or weather fronts or whatever, stable air goes back to its original location. So what are we talking about? Well, consider a portion of the atmosphere and a chunk of air or a parcel of air within the atmosphere. And if wind or something shoves that air upward, well, air pressure decreases as you go up. And so this chunk of air, this parcel of air, when it goes up higher, it experiences lower pressure, and so it expands. And what happens when it expands is that it cools down. And once it cools down, well, this air is going to contract on itself, and this denser air will then be heavier than the air around it, and it will sink and go back to its original location. And then if you have a chunk of air, a parcel of air that's up higher, and something shoves it downward, well, it's going to move to a region with higher pressure and get compressed. And as it compresses, that's going to heat it up, which means heated air is going to expand. It'll become less dense and float back up to where it was. That's stable air. Shove it up or down, it will undergo some changes. They'll bring it right back to where it started. Now, unstable air is a situation where if you have some rising air, warm air rises, it's going to keep on going. It's going to go up higher. As long as it's less dense than the surrounding air, it'll keep floating up higher and higher. And so an example might be a hot air balloon that contains some unstable air, and it's just going to rise higher and find a new location. Okay, that brings us to the concept of temperature inversion. What normally happens is that air temperatures go down as you go up into the atmosphere. That is, the air is warmer near the planet's surface, and the air gets cooler as you go higher up, and that's because of the greenhouse effect, right? The sunlight comes in, strikes the planet Earth, and right at the surface, all that sunlight is warming up the air. And then warm air rises, and so the lower atmosphere gets warmed up, but as you move away from the planet, you get higher, the air cools down. That's the normal situation. Now, if you talk about a region of air that's pretty warm and some colder air blows in, well, cold air is generally more dense than warm air. And so the air layer that's more dense is going to sink. So this cold air just got blown into this region of warm air. It's going to go below the warm air. And now what you have is the opposite of normally what happens. Normally the warmer air is found near the surface of the Earth, and it gets cooler as you go higher up. But if some air blows in that's cold, it's going to sink, and the temperature is going to be inverted. You're going to get temperature inversion. So here's a little graph, a little picture to illustrate this concept. So here down in the bottom, we got the temperature scale moving upward to the right, and the normal situation as you go up into the atmosphere, the temperature cools down. And that's what's happening here. The temperature is going down to the left as you go higher. And then if you have some warm air in here like the smoke contains warm air that rises, it's going to go up. But when it reaches this warm air, it's going to be more dense than that warm air. And so it won't rise any higher because, the least dense material is going to float, and that's this warm layer of air. And so what's going to happen is this smoke is just going to reach the top of this cold air and go no higher, and then it'll spread out. So here's two examples of temperature inversion. You got some smoke rising up here, and then there's a patch of warm air above it, and this cooler layer of air is just going to form down here, and the smoke's going to spread out and not go any higher. And over here we have a cloud on the ground, otherwise known as fog, and up higher it's all warm air, and this water vapor can't go any higher, so it just spreads out. And I said water vapor, well, that's part of the air that's really moist, maybe in here, but the little tiny droplets of water we can see, and that's forming the clouds, or in this case fog. Okay, so places with a lot of pollution will experience smog, and the smog is kept in place by temperature inversion. So in LA, Los Angeles, is right next to the ocean. And remember before we said that water can moderate air temperature, and so the cold ocean will keep the air above it fairly cool, and that can blow into Los Angeles. And then Los Angeles is close to some mountains, and on the other side there's a desert, and warm air can blow in from the desert side. And then as these two air masses meet, well, the cooler air is more dense. It's going to stay down low. The warmer air is less dense. It's going to float on top of the cooler air. And now we get the temperature inversion. Normally, you have warm air at the surface, and as you go up, it's supposed to get cool. Well, then if you have smog in here, all these pollutants, little particles of dust or exhaust fumes that collect water vapor and start forming little tiny particles of water, stuff we can see, well, that makes up smog, and it's less dense than the air around it. It rises up in here, but once it hits that warm air, it's more dense than this warm layer, and it can't go any higher, and the smog is trapped. And LA is not the only place with smog. Here's Salt Lake City. And you can see all the smog right here. It's an inversion layer. We have a temperature inversion. Okay, let's finish this first part of our weather video by talking about how clouds form. Well, first of all, air has to be lifted up in order to form clouds. And as the air gets higher, the relative humidity is going to increase. Now, why is that? Well, it turns out that warm air can hold more water vapor than cold air. And so as you move some air up higher, the maximum possible amount of water vapor in the air is going to decrease because the air is going to get colder. So remember, relative humidity is quantity of water vapor that you have divided by the maximum possible for that quantity of air, all times 100%. So let's say the relative humidity for some air right over the ocean, I don't know, maybe it contains 5 grams of water per some quantity of air. And the maximum at near the surface of the ocean, let's say it can hold up to 10 grams of water. That's the maximum possible. And if we multiply it times 100, well, 5 divided by 10 is 0.5 times 100. That's air that's 50% humid. Relative humidity is 50%. And then let's take this parcel of air and lift it. It goes higher up into the atmosphere where it's cooler. And so now the air, well, it still contains 5 grams per whatever volume of that air it is, but at this higher altitude, the air is cooler, and so maybe it can only hold 8 grams maximum. And if you get out your calculator, 5 divided by 8 times 100, now this same quantity of air higher up in the atmosphere is 62.5% humid. And if it continues to be lifted even higher where the air is cooler, well, at these cooler temperatures, maybe the maximum possible is 5 grams. And so now you have a situation where the air, having been lifted, is now at a 100% humidity. Okay, what happens at 100% humidity? Well, let's think about moving the air just a little bit higher so that it's above 100% humidity. Well, that means that some of the water vapor is going to condense into liquid, into tiny little droplets high up in the sky. And you begin with tiny little droplets, and then above 100% humidity, you're going to have more condensation, more water vapor changing to liquid, and these droplets are going to grow. As the air deposits more water vapor into these droplets, the air itself is going to hold less water vapor, right? Because some of the water is now in these droplets. At that point, the air will be 100% humid, and water vapor can evaporate out of these little droplets, and the droplets will shrink. And that new water vapor can go to a new droplet and make it grow as it condenses, and back and forth it goes. And this is going to make up a cloud. These little droplets are big enough to see under a microscope, but without a microscope, they're going to scatter light, and we're going to see these little droplets as that foggy haze that makes up a cloud. And when there's enough water vapor condensing to form large droplets of water, typical raindrop, it's pretty big, then it'll be heavy enough to fall. And that'll be rain. Okay, that's enough for now. Take a look at part 2 when you're ready.